everyone, I'm Nurul Hazrina binti Nordin from UMPSP STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to Chapter 5 GPIO Pins Overview. In our microcredential course, Raspberry Pi Installation and Configuration. In this session, we will explore how to use Raspberry Pi General Purpose Input-Output or GPIO pins to control external devices such as LEDs, buttons, and sensors. By the end of this lesson, you will be able to write Python programs to interact with Raspberry Pi and the GPIO pins effectively. By the end of this chapter, you will understand the layout of Raspberry Pi GPIO pinout diagram. You can gain hands-on experience connecting external components to GPIO pins, and you can write Python scripts to control GPIO pins for input and output operations. GPIO, General Purpose Input-Output Pins, allows Raspberry Pi to communicate with external components used to control LEDs, buttons, motors, sensors, and more. This pin can be programmed for input, reading data, and output, sending signals. This is an example of Raspberry Pi GPIO pinout diagram. This is the Raspberry Pi 4 GPIO pinout diagram. The Raspberry Pi has 40 pins. Category 1 is the power pin, 3.3 volt and 5 volt. Now these power pins are color-coded in red. The power pin provide power to the external component. The ground pins serve as reference points for the electrical circuits. Secondly is the ground pin, where they serve as the reference point for the electrical circuits. The third class is the GPIO pins, numbered 2 to 27, are the programmable and can function as inputs and outputs. And the final class are communication pins, which includes I2C, SPI, and UART for connecting external peripherals. We use rpi.gpio library in Python. This library provides a simple way to interact with the Raspberry Pi GPIO pins, allowing us to control electronic components such as LEDs, buttons, and sensors. The first step is importing the libraries. Before we can control the pins, we need to set the pin numbering mode. The Raspberry Pi has two ways of referencing GPIO pins. The first one is the BCM mode. This refers to the Broadcom GPIO numbering, which follows the internal hardware design of the Raspberry Pi. For example, GPIO 18 corresponds to a specific pin, but its location may vary depending on the Raspberry Pi model. The second mode is the baud mode. Now, baud mode uses the physical pin numbers on the Raspberry Pi's GPIO header. For example, pin number 1 is always in the top left corner of the baud. To select a numbering mode, we use the following command: gpio.setMode GPIO BCM for Broadcom. Here is an example of Python codes for Raspberry Pi. Let's have a look. What is the typical structure of coding Python for Raspberry Pi? We begin by importing two essential libraries. In this case, it's rpi.gpio, which allows us to control the Raspberry Pi's GPIO pin. And secondly is time, which enable us to introduce delays in our code. Secondly is setting up the GPIO mode. So in this case, we configured the GPIO pin numbering mode. The Raspberry Pi has two numbering systems as mentioned earlier, BCM or baud. So in this case, we are using GPIO.BCM. And step number 3 is to configure GPIO 18 as the output, such as the one shown here. We set the GPIO pin 18 as an output pin, meaning it will send signals to the connected components such as an LED. And step number 4 is to write a blinking loop. We then enter continuous loop. So what is being mentioned here is that we will turn the LED GPIO 18 to high. We will wait for 1 second using the time.sleep function and turn off the LED by setting the GPIO 18 to low. We wait for another 1 second before repeating the instructions.